Hi everybody. This is the Math Core's The Real Numbers course. My name is Mr. Nazelli and I'm really excited to get the chance to talk with you about the real numbers. Our first lesson will introduce the whole numbers, a very special subset of the real numbers. So let's get right down to it. Before we get to the mathematics, I want to welcome everybody to the Math Core and to this course. I'd like to lay out a few expectations that we have about how you will interact with and around these instructional videos. When you are watching this video, we think you should be ready, intellectually ready. And what that means to us is you want to have your notebook open, your pencil in hand, ready to take quality notes. Those can be things that strike you as important, questions that you have about anything that you see or hear, and they might be answered later in the video. It might need to get answered after the video is over. But taking good notes is a skill that's going to stay with you and be very important all the way through college. Okay, so we want you to practice that. Stay active with this. This is the Math Core. So you understand we are really going to push you to show your courage to overcome your fears. And in this context, the most important one is the fear of getting something wrong, the fear of making a mistake. I know it's really hard, but I also know that that's the way that people learn best, by making mistakes, being aware of them, and then fixing them. Okay? You should know that everybody in the Math Core will be there to support you if you try to stretch yourself, to go beyond your comfort zone, to really challenge yourself intellectually. People will be there for you. Okay? Now, I'm going to leave how you will discuss this with your colleagues, your TA, your CI. I'll leave that up to you. But what I would suggest in those electronic discussions, I'd still say you probably want to be raising your hand if you have something to contribute to the discussion. That'll make that discussion go a little bit more smoothly. And then also, I want to encourage you to use your signals. Even if you're by yourself, it might seem a little weird, but the signals are really for others to see. So if someone's saying something that you agree with, you can give them our agreement signal. If you disagree with something, you can non-verbally disagree like this. And then if somebody's trying something that's difficult for them, really putting themselves out there, then you can give them some support this way. Okay? All right. That's it for the preamble. Let's get to the mathematics. This course is all about the real numbers. The real numbers are the most important set of numbers that we've got, and they are everywhere. Now, to make sense of that, it helps to have a visual. And we like to think of the real numbers as all the spots on the real number line. Every number has its spot on the number line, and every spot represents a different real number. So here is a real number line. I'm going to put a few numbers down here for us just to get us started out. So I'm going to start with 0. It's a good one to start with. If I jump over a little bit to the right, that's where 1 lives, the number 1. Jumping over a little bit, that same amount to the right, we see that's where 2 lives. And we can keep going. That's where 3 lives. Give me another suggestion. You guys just yell them out. At top of your lungs, scream it out. Okay, all right, thank you. I heard 23. You guys probably heard that too. So I'll tell you what, it's down there, down a ways from 3. So let me put a little break here in our number line, and then I'll put 23 right there. Okay, so down the line a little bit is the number 23. I'm not sure if anybody was wondering, there is some space to the left of 0. You might be thinking, well, what's going on over there? Well, there are numbers to the left. We call them the negatives. And we're going to talk about those soon, but not quite yet. Okay, so that's why I just kind of ignored them and sort of pushed them off to the side. Don't worry about that. You also might be wondering, well, how about the numbers in between 0 and 1, or between 1 and 2? It's a great question. We will also deal with those numbers as well very soon. But for today, and maybe tomorrow, we're going to concentrate strictly on these numbers to the right, from 0 and to the right. We call them the whole numbers. The whole numbers. And just so everyone is clear, those are the numbers 0, 1, 2, 3, etc., 23, etc. And by the way, did you notice the ... at the end? That means that they keep going. So I didn't put a last whole number down there. Well, that brings up a good question. Is there a biggest whole number? Is there a number that should go there? Well, just scream something out. Wait, I can't hear you. Louder. Yes, yes, good. I don't know if you guys heard, but I sure did. Let me, again, it's going to be way down the line. I heard somebody yell, 8 million. 8 million. Okay, that's pretty darn big. Is that it? Is that the biggest? Yeah, I'm with you. I don't think so. Look, there's more space there on the right, right? It looks like there's stuff past 8 million on the number line. And you know what? You're exactly right. It turns out that the whole numbers, there are an infinite number of them. We could just keep going to the far, far right. Just get bigger and bigger. There's no end to the whole numbers. There is an infinite number of whole numbers. We could get huge. Well, you might sort of get a little bit scared, a little bit nervous. Like, wow, man, there's a lot to know about these whole numbers. Well, it turns out we think there are 5 things, 5 key things that you need to be able to do to really sort of know how to work with these whole numbers. And we're going to talk about them really quickly, okay? Number 1, you need to be able to read and write these whole numbers. So, for example, take this gigantic number. I don't know if anybody yelled that one. Anybody yell that particular one? No? Okay, it's probably a good thing. But look at this. This is a big number. But I want to draw your attention. If we want to read this, it turns out if you can read those 3-digit little groups that you see separated by commas, that's all you need to know. Sort of. Look at this. If you notice, there's 3 digits, comma, 3 more digits, comma, 3 digits, and a comma. Well, those commas separate really important groups. And I just want to point out, this first one, moving from right to left, that marks off where the thousands group is. And then the group to its left is the millions group. All right? So if you know those names, the names of the groups, all you need to do then is to read those individual groups of numbers. So for example, let's start on the far left. That's how you read numbers, just like English. I see 4, 8, and 2. So as a 3-digit number, that would be 482, correct? So 482, and now I know because of that comma that I'm in that group, that's 482 million. In the next group of 3, I see, 57. Notice there's no third digit. We hold that place with a 0. So I'm just going to read what I see there, and that's really 57. 57,000. And then the final group, it's just simply 603. That's all you need to know to be able to read these numbers. If you can read a 3-digit number and you know the names of those groups, then you're all set. If you want to write it, we write it just as we just said it. It's a little bit of a chore. Let me give it a try here. I'll write it for you. Again, left to right, we said that we had 482 million. I'm going to, and by the way, see the comma there? Just like in English, we'll do it like we do with the numbers, comma. I'm going to go to the next line because I think I'm going to run out of space. Excuse me about that. 482,057,000, comma, 603. There it is in English. Okay, you can sort of see why the digits are much nicer to write than to write it in English. But there it is. Okay, who knows? You might have to write that on a check someday in English. Does anybody use a check anymore? Anyway, looking okay? All right, if we move on, just very quickly, you also need to be able to count these with these whole numbers. And I think you're probably pretty solid on that. I just want to point out one small trouble spot got to watch out for. And that happens when you turn from one of these groups to the next. So for example, if you were counting 997, 998, 999, the next whole number up is a new thing. That new number is 1,000. So we've moved from that first group of 3 to the second group of 3, which we saw was thousands. So this is what we're calling the turn to a new thing. And the all nines is like the real tip-off. That's some, probably some big, 3 nines, excuse me. All 3 nines means you're going to move into that next group. Here's another example just to clarify. Oh, and let me just say, on that one before, after you get to 1,000, the next number is 1,001, 1,002. Just keep going. In this next example, we have 999,998. The next whole number up is 999,999. And then the next one, see those three nines, both groups? The next turn then goes from the thousands to the millions group, doesn't it? It's 1 million. Okay? That's it for counting. Now, I will say that even though you only need to be able to say those 3-digit numbers to read them and to write them, the place value system is really super deep. So cool. The inventors of that, man, that was something. But let's take a look inside those place values just a little bit more deeply than just this is the thousands group, this is the millions group, etc. But inside those 3, the cool part about this is, look at this gargantuan number. The nicest part, in my opinion, of this decimal place system is that there's this consistent structure all the way through. And here's one part of it. If you look at that lowest group of 3. We've got the ones, we have 9, the digit in the ones place, 5 is the digit in the tens place, and 3 is in the hundreds place. That's why we read that as 359. Okay? So we got 1, 10, one of them, 10 of them, 100 of them, and now when we move to the left, we are now moving into the 1,000 group. We have that same structure. 1 of them, 10 of them, 100 of them. But this time, it's not 1, the 6 is not in the ones place, it's in the 1,000 place. So we have 6 thousands. We have no 10,000s, that's why we're holding that place with the 0. But we have 2 in the 100,000s place. Okay, so again, 1 of them, 10 of them, 100 of them, in this case thousands, and then new thing. And we know that that new thing is the millions. And again, 1 of them, 10 of them, 100 of them, these are all millions. 1 million, 10 million, 100 million, and then billion. We've got the 6 in the 1 billion place, or the billions place. 3 is in the 10 billions place, and 4 is in the 100 billions place. Isn't that nice? Just continues on all the way. 1 of them, 10 of them, 100 of them, new thing. Okay? All right. The fourth thing you need to know, just very quickly, is you need to be able to approximate, have sort of a number sense that allows you to approximate whole numbers. And just as a quick example, if you go into a store and you see something is listed as costing $498, well, you really want to be able to very quickly understand that since 498 is very close to 500, that this is essentially, the price tag here is essentially $500. Very, very close to $500. That's it. I'm not going to say much more about that. I'm going to let you practice some approximating. But this should make life easier on you. You can approximate these to nicer numbers that are easier to work with. That's the whole deal with approximating. Okay, I'm going to let you try that with your colleagues. Okay. The last thing is that you need to be able to operate on these real numbers. That is, you need to be able to add, subtract, multiply, and divide. You need to know the algorithms, the process to do each one of these operations, the standard one that we learn in school. I don't have a lot of time to go through each one of those. Again, I'm going to ask you to do that with your colleagues. You can practice that on the homework. But I do just want to show you one very cool thing. It has to do with multiplication. So if you look at these 3 problems, I don't know if you've ever noticed this, but when you take a whole number and multiply it by 10 or 100 or 1,000 or 10,000, these powers of 10, they're actually the place values, aren't they? If you multiply by one of those, it turns out to be super easy to get the answer, to get the numerical answer. And if you look at it, we can say it like this. 32 times 100, well, it's just going to be the 32, and then you tack on the 2 zeros that you see right there. So 32 times 100 is 3,200. The numbers there you can see just play out. The 2 zeros right here are there. Okay, 32 times 100 is 3,200. If we put in our commas to help us keep track of it, we see that's really 3,200. That's how we could say that. Likewise with the second one, 305 times 10,000. All right, well, I know I'm going to get my 305, but this time we need to tack on 4 zeros. Okay, and again, I'm going to add my commas there to keep things grouped, and it looks like we end up with 3,050,000. Okay. Now the last one's a little bit more difficult, and you might think, well, okay, it's not 10 or 100 or 1,000, but if we can be clever with this, watch this. 43 times 2,000, see if you guys agree with this. 2,000 is really 2 times 1,000, right? That's just kind of doing what we were doing in the previous 2 questions backwards. We're taking 2,000 and breaking it up into 2 times 1,000, because that lets us multiply those 2 together first. And the nice thing is I might even be able to do that in my head. 43 times 2 is 86, right? Now, we still have this times 1,000, but now we're back to what we were just practicing above. 86 times 1,000 is 86. 3 zeros, it's 86,000, right? Look at that. So that's nice, sort of breaking that 2,000 up into a little mini multiplication problem of 2 times 1,000. Hope that's looking okay. All right, I'll tell you what. I'd love to get out of your hair and let you guys get to work with your colleagues and your TAs and CI. So what I'll say is, until tomorrow, I'm looking forward to seeing you in our next lesson, where we'll continue talking about the real numbers and in particular the whole numbers. See you later. Nice work today.